Robin will talk to us about the famous fall armyworm, the worm that is causing a misfit in her mielies. She said specifically my mielies, and she's going to explain why. Thanks.
Thank you so much, Paulo. Thank you to everyone for allowing me to talk today and to give you some interesting projects that we've been running, all related to fall armyworm. And I do refer to it as the misfit in my mielies. You'll find out a bit later in the talk, but I've actually planted a hectare or two of maize myself, and I learned a lot. So let's get started. A lot of people have heard about fall armyworm. It was recorded or had an outbreak in 2017 in South Africa. It's a polyphagous pest that's classified as an A1 quarantine organism in Europe and the Mediterranean Plant Protection Organizations. It's a quarantine pest in South Africa. We had a sample sent into us, and our very own entomologist, Vivian Ace, did the morphological identification. There we go. There's eight species known of Spodoptera in the Afrotropical region. The fall armyworm identification was done by using the male genitalia, and it was specimens from the South African National Collection of Insects was used to compare. And I can tell you, I've seen someone do a genitalia dissection on a moth. It's a very complex process, and if you'd like to see it yourself, there's a link to the YouTube video where Vivian actually explains how it's done. And then further, once the morphological ID was done, they used CO1 barcodes as well as TPI to help confirm the identification. So just to give you some background about the South African National Collection of Insects, it's now over 100 years old. It has an extensive taxonomic, biological and biogeographical reference source for the Afrotropical region, and it has a number of different orders in it. You are welcome to reach out to the entomologist or to me here at Biosystematics to access and to make use of it. It's really an amazing collection, truly amazing. So what happened after we had the accurate ID? So I was very fortunate to be involved in the spin-off projects or spin-off training projects. There were a lot of other research projects done by our insect ecology colleagues. And the first of that was a SADC regional training. So basically what happens, there was a big conference, this is obviously before COVID, in Botswana, where the STORA project was established. This is Project STORA stands for the Support Towards Operationalization of the SADC Regional Agricultural Policy. And the aim of it is to enhance information of agricultural production, sustainability and competitive for evidence-based decision-making, and improving access to markets through the implementation of plants and animal pest and disease control strategies on a regional level. So when they talk about regional, it's throughout the SADC region, and then facilitating implementation of some components of the regional food and nutrition security strategy, which is actually very exciting. So working within the SADC region to try and control fall armyworm, and there's different languages. It's a very different experience to actually be involved in a regional training event compared to a national one. So there were two week-long training workshops held. This was lucky. We literally got this training through just before we went into our national lockdown. We didn't just include fall armyworm. The FAO selected, there's two other pests and diseases. So it was fall armyworm, tuta absoluta, and maize from the necrosis disease, but we're only going to focus on fall armyworm. And what we did is we started with identification and the taxonomy. It wasn't just, oh, you look at a slide and you see it. There were physical samples with physical damage. They did the biology and the ecology of fall armyworm, different methods of control. As you know, there's various methods from cultural control to biological control to chemical control. Then each country within the SADC region gave the feedback of what they are doing, what they would like to do, and then there was time to sit and develop a regional strategic management plan. So it's a very intense week-long workshop that takes place. And as I said before, it contains both of theory and hands-on training. There was PowerPoints, as well as actually going for the participants could see the specimens at its various life cycles. They could see the damage on the maize at different stages. So we spent a lot of time planning and preparing for this workshop. And From this workshop, we then spread down into a regional workshop, into a national workshop, which was very similar to what we did in the SADC region. It included more pests and diseases. It had fall armyworm, Tuta absoluta, the ornamental fruit fly, as well as maize needle necrosis, and TR4, which is a fungus that attacks bananas. And it was, the people trained were national and provincial agricultural staff. The only problem was this happened post-COVID, as you can see from all the masks. And we had to basically fit in what was done over 2 weeks in South Africa for those 3 pests and diseases. We had to squash in a week, so it was very intense. There were representatives from all the provinces except the Western Cape. It's because they don't have fall armyworm presence. They also have different planting seasons to the rest of the country. If anyone was wondering. Okay, so this is where I get really excited. This was an amazing project to run. We then rolled out from the national training. We actually went to 2 communities and we rolled out training with the smallholder farmers. So we did what we call the FAO, Fall Armyworm Farm and Field School. The FAO is the Food and Agricultural Organization of the United Nations. And we were approached with the FAO and through the Department of Agriculture, Land Reform and Rural Development to roll out a farmer field school. The idea with this was when I say we as the ARC, we've done a lot of research projects on fall armyworm, and our Institute of Plant Health and Protection is very well suited with that background to actually roll out a farmer field school. So what happened was 2 communities were selected. In those communities, 20 women and youth were selected to participate, and we chose 2 communities based on their proximity to the neighboring countries, as well as the research we've done. We found out that these are fall armyworm hotspots where they can overwinter. So just to give you an idea of where these communities were based, the one was the Chamba community in Thohoyandou, and the other one is the Makukeni community, which is about about an hour and a half from Mielies, and it's literally 4 kilometers away from the Swaziland border. So it was quite an exciting project, to say the least. So what were the flow of activities for the Farmer Field School project? Well, first we had questionnaires with the participating members of the communities. Step 2 is we did agri-seeder training. Step 3 is we did a field trial where the community or the staff, the ladies being trained, actually could implement the skills that they learned from the agri-seeder training. So the first questionnaire, we luckily again just got this out before we went into our level 5 lockdown. And the questionnaire is related to their socioeconomic circumstances in the community, what they use to control fall armyworm, do they use pesticides, do they use a cultural control method? So this helped give us an idea of what we would do when we actually got to the field trial part. So after we eventually were allowed to travel, we did our agri-seeder training. This was done early September, and we provided agri-seeder training because it's nationally recognized, and we covered 3 different unit standards. So that this also enables the trainees to potentially use this qualification for future employment. Then step 3, which is probably the most challenging part of it all, and everyone kept telling me once the seed is in the ground, it'll be easier, which is not the case. So here you can see 2 examples, or the 2 field layouts we did. Ideally, we would have liked to have the Makukeni planting layout, which is a randomized square design. But given the layout of the Chamba land that we got, we had to adapt. So what we did is we divided into different squares, 3 to 4 replicas of each treatment with 4 treatments. The first treatment was genetically modified maize. The second treatment was conventional maize with no control, so that we just left it, we applied nothing to it. The third treatment was the conventional maize with a cultural control, which is the application of ash into the growing points of the maize. This came out as a method used by both of these communities to control the fall armyworm. Treatment 4 was the conventional maize with the chemical control, which is the application of pesticide. So this is a very simplified version of the activities that took place. We planted by hand with the ladies and the youth in the community at each planting site in late October. And then we went back about 2 weeks later, applied our fertilizer. And then with the FAO, we showed them how to use the Farm Use Fall Armyworm Monitoring and Early Warning System app. This is something that the FAO has rolled out throughout the continent to specifically help smallholder farmers monitor fall armyworm. After that 2 weeks, or at that 2 week period, we also started monitoring for fall armyworm, and then we started the application of the treatments, which was applied throughout the growing season until the maize got too big to comfortably apply the ash or the pesticides. So the monitoring of the fall armyworm is done weekly by the communities, and the ARCs, the site visits monthly. And then in the true experience of this entire project, nothing can always go according to plan. When we were hoping to harvest, Cyclone Eloise hit, and the roads and the planting sites became so wet it was inaccessible. So we ended up only harvesting in April 2021 of this year. And we did this again for the first few days with just the ARC team, where we collected the data that we wanted, and then the rest was done with the communities, with the ladies, where they actually showed us how they do it and how they traditionally they remove the kernels from the cob. It was a real eye-opening experience, and then we completed it. So one of the most amazing take-home messages for me was that the application of ash into the growing points of the maize does actually seem to control for armyworm really well. It's quite a cheap method compared to pesticides. A small bottle of pesticide can be a couple thousand rands, where ash from your cooking fire can be used. Literally, you apply it to the growing points of maize, and it actually helps to control the fall armyworm. We weren't able to show this statistically yet. This is just very preliminary results, and we really are hoping to do this project again with a different community, because we learned a lot this time around, myself and the team. And some of the big lessons we learned is that ownership of the end product, which is the maize, is really important. At the one planting site, the maize belonged to the ladies who did the work, and the other side was to the chief. There's very big differences in expectations what people experience. Ongoing community is really important. Communication is really important, and it's on the various scales that a project like this needs to be done. It's really, really important. And you really need to have trainees who are passionate about agriculture, because agriculture is not easy. I learned that the hard way. So I just have to go back to what Fuller said about my maize. You can see two pictures of our beautiful maize growing. I literally felt like I shed tears next to these maize fields, and I helped plant them. So it was a really humbling experience in my own mind. And then it's really important to meet all the role players, not just the agricultural representatives or like that, to actually go to the community and meet the community before you start, so that everyone's on the same page when you begin. So it was really cool. So our proposed way forward is we'd really like to do this again, and we'd apply a lot of the lessons that we learned the first time around to this, which would make it much easier. Then we really have to send a massive thank you to both the communities we worked in. The ladies, they were amazing. The provincial representatives from the local agricultural departments, they helped us every step of the way. We'd like to thank Bayer for the sponsorship of the seeds and the cutworm application used in the trial, as well as to the local agricultural college in Johambo for their maize thrasher. Traditionally, maize is removed by hand off the kernels by the ladies there, and the maize thrasher just helps speed up the process a lot. So it was, it's an intense experience. So what made all of this possible? And it seems very random all out there, but if we did not have an accurate identification of that pest, we would not be able to do anything. It's essential to be able to know for sure what you are dealing with, to be able to control this pest properly. So for that, you need taxonomists who are skilled and knowledgeable and able to do accurate identifications. And if you don't have an accurate identification, the research you are going to do is going to be flawed. You're not actually going to know what you're dealing with. And those taxonomists are linked to collections, and without those collections, there's no way it could happen. So I just want to say thank you very, very much. Thank you for joining me in my excitement of my mielies and my mischief in my maize. Thank you, everyone.